Now we will go to Croatia, and we shall call the young researcher Inova. I have difficulties to pronounce her surname. I'm sorry for that. Ivkic, possibly something like that, to present her research about the Karst poljes as natural archives of Quaternary environment change studies from the Dinarides. Inova, okay.
Ivona.
Inova, I'm sorry. Yes, the floor is yours.
Thank you very much, Professor. Can you see the presentation? Can you hear me?
Yes, everything is very well.
Full screen, okay. So thank you to the organizing committee and Professor Ivkic for this opportunity to represent my research. I am Inova Ivkic Filipovic. I'm a PhD student from Croatian Geological Survey, and today I would like to present you so far paleolimnological research that was conducted in the Dinarides, and I will actually present you two case studies, one from the Adriatic coast and one from the central Dinarides, so it's a more hinterland area. So the topic is the Karst poljes as natural archives of Quaternary environmental change. And one case study is actually part of my PhD project. So I have a confession to make. I'm actually paleolimnologist and not geomorphologist, but geomorphology is a major part of my PhD. So I would like to share you my research. So to start with the definition of karst poljes, these are the largest and most prominent karstic features, although they can be very variable in size. Let's say from 1 square kilometers to nearly 500 square kilometers. They are commonly defined as a flat floor depressions within high mountainous areas, made mostly of limestones and dolomites. So these are practically rocks that are very prone to the dissolution processes. One of the major characteristics of the karst poljes is these very unusually flat and large surface areas that has a very sharp boundary with the surrounding mountains made of limestones. These flat floors are associated with various types of depositional environments, mostly alluvial and lacustrine sedimentation. And these processes resulted in the vertical aggradation of the sediments, which in the end resulted in these flat floor surfaces. Karst poljes are known for their remarkable landscapes. They have many geomorphological and hydrogeological features. They are formed by combined processes of tectonics, weathering, karstification processes, and sedimentation. The main factors, of course, controlling these development of these features are groundwater and regional geology made of soluble limestones and dolomites. So the term polje actually originates from the Slavic languages, and it literally means a large field or a plain. And one of the best examples can be found within the Dinarides. So the Dinarides or Dinaric Alps are a mountain range situated in the southeastern Europe, and it separates the Balkan Peninsula from the Adriatic Sea. Dinarides are mostly consist of Mesozoic to Cenozoic sedimentary rocks, such as limestones, dolomites, and various clastics, which are associated with different types of marine and terrestrial environments. Dinarides formed during the Alpine orogeny, or Alpine, which lasted from the late Mesozoic to the Cenozoic era, when the Adriatic microplate collided with the Europe. This process is still active today, and the Dinaride region is a very seismically active region. So as I mentioned earlier, tectonic movements, regional geology, and karstification processes developed or generated, should I say, one of the best examples and largest karst poljes in the world. Dinaric karst poljes are actually defined as structural type of poljes, meaning that their development was controlled by a bedrock geology. They are typically elongated in accordance with major structural units like major faults in the northwest and southeastern direction, which is often called as Dinaric strike. And this implies the importance of tectonic movements on their formation. You can see it here in this scheme of the structural polje, that the basin morphology is governed basically by the major fault systems. But also the infilling of the polje is controlled by the subsequent erosional process and depositional processes, mostly alluvial and lacustrine sedimentation, which dates all to the Neogene. These Neogene deposits in one of the largest poljes, like the Livanjsko polje in Western Herzegovina, can reach nearly 2,500 meters in thickness. Another major characteristic of the polje is these ponornica rivers. These are actually surface streams which spring on one side of the polje, flows all across the polje and branches into many smaller streamlets, and they eventually sinks on the other side of the polje. And these surface streams played also an important role in geomorphological shaping of the entire karstic landscape. Common depositional environments within karst poljes are karst lakes. Here's one example of karst lake. Wetlands, peatlands, and various types of alluvial sediments, on top of which are very fertile soils developed. Thanks to these fertile soils, poljes were important economic and agricultural centers since the ancient times. And practically they have remained the only fertile regions within the Dinarides, within the barren karst. Within the context of Quaternary environmental change, they served as a valuable sediment traps. They have preserved fluvial, lacustrine, glacial, fluvial, aeolian, etc., similar deposits, which can offer us a very valuable insights into the late Quaternary paleoclimate and environmental changes. So the question of interest regarding the karst poljes is that are the karst poljes ancient lakes or paleo lakes, and why do we need to explore them? This generally can be answered through the paleolimnology, which is a multidisciplinary science about past conditions and processes in lake basin. So paleolimnologists use various physical, chemical, and biological parameters to define the basin morphology, basin composition, and internal configuration. This is usually achieved by drilling methods, multi-proxy core analysis for geochemistry, sedimentology, mineralogy, etc. And the entire drilling process is usually accompanied by geophysical and remote sensing methods. All of these results can help us to assess paleoclimate influences, tectonics, human influences, and sometimes possibly mineral resources. So far, paleolimnological research in the Croatia within the Dinarides revealed 4 main types of karst lakes associated with karst poljes. These are permanent karst lakes characterized only with seasonal variations of lake levels. Next, we have intermittent lakes like floodplains, wetlands, peatlands, marshes, etc. Paleo lakes, which existed in some point of geological past, but now they are naturally or artificially drained. And they are usually of Quaternary or Neogene age. And in the end, we have drowned paleolakes, which can be tracked along the eastern Adriatic coast. So we all know that during the last glacial maximum, the Adriatic coast was nearly 120 meters lower than today. So all of this was a great plain with various terrestrial environments. Research drilling along the eastern Adriatic coast revealed the existence of these ancient paleolakes, which can be tracked to the late Pleistocene. Nowadays, of course, they are drowned under the influence of Holocene sea level change. So basically, we can distinguish the two main types along all of these lakes. These are the lakes that were influenced by the sea level change during the Holocene or post-LGM. And the second type of lakes are these lakes situated within the so-called high Dinaric Karst zone, within the high mountainous regions. And they were probably more influenced by the changing precipitation and glacial fluvial processes, in contrast with these lakes along the coast that were influenced by the sea level rise. So I would like to present you now shortly two case studies. One is Bokanjačko Blato, situated on the eastern Adriatic coast, and the other is Prološko Blato, which is a part of my PhD research, situated within the high Dinarides. So the Bokanjačko Blato is a Holocene paleolake along the eastern Adriatic coast, situated in the Zadar County. Here we conducted a percussion drilling combined with a GPR survey to determine the paleolake evolution. Sediment cores were analyzed in high resolution for geochemistry, sedimentology, mineralogy, and micropaleontology to assess the paleo-environmental conditions. I don't want to go in the details of these results. I only want to share you the main conclusions of both study cases. So the lake evolution of in the Bokanjačko Blato can be tracked from the early Holocene, when a smaller and shallower lake probably existed with dominantly siliciclastic deposition. This can be usually tracked by the higher values of magnetic susceptibility and the higher content of the so-called lithogenic or siliciclastic elements, such as alumina, iron, copper, etc. All of this points to the increased erosion in the lake catchment. This was probably influenced by the wetter climate conditions in this part of the Adriatic during the early to middle Holocene. The siliciclastic deposition was gradually replaced by a carbonate sedimentation. Sorry, I just want to ask you, I don't know if I have a full screen showing.
No, you do not have a full screen.
You should have warned me.
But we can see.
We can see, but it's better if you share full screen.
It's a bit confusing. I apologize for that. Let me try. Yes, this is now okay.
Yeah.
Yes.
Thank you.
So this is the Bokanjačko Blato, and here are the results of our multi-proxy analysis, right? So where was I? Siliciclastic deposition was gradually replaced by carbonate deposition. You can see that in the late Holocene up to present, we have values of the magnetic, also lower values of alumina, which points to the usually to erosion from the catchment, but also higher content in calcium. And this points to the more carbonate sedimentation and lake level, generally lake level rise. The lake level rise was under direct influence of the sea level rise during the late Holocene and during this period, late Holocene. As you can see here, this is the reconstruction of the changes in lake level in accordance with the sea level rise during the past 10,000 years. And in the 60s, lake was artificially drained for agricultural purposes, which can usually be tracked by higher values, higher content of, for example, phosphorus, magnesium, lead, copper, etc., which points to the anthropogenic influences such as fertilizer uses or even atmospheric pollution. So with this case study, the Bokanjačko blato is a type of a karst depression, which was strongly influenced by the erosional processes linked to climate change and sea level rise over the last 10,000 years. Next case study is part of my PhD project. It's called the Prološko blato in the Imotsko polje. The Imotsko polje is one of the largest Dinaric karst poljes in the Croatia. It is mostly built of the Mesozoic carbonates like limestones and dolomites, and it is entirely filled with Quaternary deposits. The Imotsko polje is a very popular tourist spot. We have here the world-known Red Lake and Blue Lake, which are collapsed sinkholes near the city of Imotski. And I should warn you, this is not the photoshopped image of the Blue Lake. It got its name for this beautiful color, which can be seen usually after very heavy rainfalls due to the high groundwater discharge. And the Blue Lake sometimes dries out, so the locals traditionally play football on the drained lake floor. Imotsko polje holds many karst lakes, not only just Red Lake and Blue Lake, but also the Prološko blato and many other smaller lakes within the polje. And all of these lakes are actually collapsed dolins or sinkholes filled with water. So the Prološko blato is actually a typical karstic wetland landscape. I will show you. It's located in the southwestern part of the Imotsko polje. This is a typical wetland landscape, and seasonal variations in lake level turns the environment from wetland to grassland. And these lake level fluctuations are the main erosional processes that is happening in the research area. And these erosion processes leave behind these very distinctive erosional channels that in summer period are very suitable for mapping and sampling of the Quaternary sediments. And here is the zoom in on the Prološko blato. So far, we have conducted geomorphological, geophysical, and sedimentological research in the area, and the preliminary results points to the next conclusions. The Prološko blato can be roughly divided into two parts: the Prološko lake in the eastern part and the Prološko paleo lake in its western part. The Prološko lake is actually a mesta well, meaning that it serves as a karst spring in wet part of the year and also as a swallow hole or ponor in the dry part of the year. And it is classified as a collapsed sinkhole. Prološko paleo lake deposits were actually recognized thanks to these erosional channels. Here you can see beautifully fine layered lacustrine sediments that can be traced erosional channels. So actually, when the water retreats sometimes in late summer to autumn, we can come here and conduct various types of field research. So the geomorphological characterization was conducted based on the GIS analysis, GPR survey, drone survey, etc. And thanks to this analysis, we were able to characterize geomorphologically the entire region. So the Prološko Blato actually belongs to the wider Ivkic Lake system. As you can see at the very glance, this region is characterized by many types of sinkholes, which I marked in these colors. So the brown colors, three major types of sinkholes can be recognized. These are collapsed sinkholes, buried sinkholes, and subsidence sinkholes. So the collapsed sinkholes I marked with brown colors. They are formed within the melic carbonates, and they are the result of the dissolution and rock failure into the underlying cavity. These are the Prološko Lake, Filipovac Lake, Knezovića Lake, and Mamića Lake, and many other sinkholes that are not filled with water because they have not reached the groundwater level. Next, we have the subsidence sinkholes, which were formed by the downwashing of soil into underground fissures and cavities. And these are the Bučiša Lake and the Krenica Lake. So these are all local in names and not formal names. They were, for example, Bučiša Lake was formed in 2004, and the formation was documented by the locals. The subsidence lasted for about a month, which means that these small lakes are actually actively forming in these in the Prološko Blato area, which led us to the conclusion that in this that along the edges must be buried sinkholes that are actually reactivating due to the fluctuating seasonal fluctuations of the water level. One of the major hypotheses in my PhD is that these buried sinkholes served as a sediment traps during the late Quaternary, meaning that the Prološko Paleo Lake developed within these buried sinkholes. And this needs to still be confirmed by the GPR survey. Here is the slope analysis of the entire research area. I wanted to show you this because you can see that the edges of the Prološko Blato is characterized by very steep slopes. You can see that it is nearly vertical, which additionally supports this idea that in the edges can be found the buried sinkholes. So if we take a cross section across the Prološko Lake, and here you can see the cross section of the Prološko Lake, you can see it's a steep slopes that are nearly vertical. Cross section points to these beautifully ball-shaped collapsed structures, which led us to the conclusion that the Prološko Lake must have formed by the collapsing event, and that this collapse event must be younger than these Paleo Lake deposits. As you can see in the other cross section here, here you do not see the carbonate bedrock, only quaternary sediments. So basically we have two systems. We have Paleo Lake, which existed from the late Pleistocene to the Holocene. I will come to that. And in this eastern part, we have Prološko Lake, which was formed as a result of the collapsing event. Sedimentological characteristics were determined again with percussion drilling in the polje, sediment sampling within erosional channels. And again, we conducted high-resolution core analysis for mineralogy and sedimentology, geochemistry, etc. And also this was supported with the radiocarbon dating. So the major conclusions are as follows. The radiocarbon dating revealed that the siliciclastic sedimentation prevailed from the late Pleistocene to the middle Holocene, and was marked by the coarser grained sediment deposition such as sands, silts, and gravels. Next, from the middle Holocene to around 900 years before present, the siliciclastic deposition was suppressed by the altigenic carbonate sedimentation. This is also a lake carbonate chalk characterized with the very high content of calcium, calcite, and it is very rich in microfossils. Around 900 years before present, abrupt change in sedimentation happened. We have a change from carbonate sedimentation to the, again, siliciclastic brown clays. And this is the very interesting part that I will discuss. In contrast to the previously mentioned Bokanjačko Blato along the eastern Adriatic coast, we can clearly see that the late Pleistocene up to the middle Holocene was very dynamic in this part of the high karst, the high Dinaric karst, which can see by these gravels, sands, and silts, so coarser grain deposits. And the remaining part of the Holocene was characterized by more altigenic sedimentation. And somewhere around 900 years before present, this is again one of the possibilities, the abrupt change in sedimentation possibly was triggered by the collapsing of the Prološko Lake, as you can see here in its eastern part, which led to the disappearance of a paleo lake with relatively constant water level and development of the modern Prološko Lake, which is actually an estavel today, with seasonal flooding and wetland conditions. I just wanted to show you two different cases that was so far studied along the within the Croatia. We have also studied the drowned landscapes along the eastern Adriatic coast, but I don't have time to go into any more studies, and I would like to conclude with these two cases. So another characteristic of the Dinarides is that the long sedimentary sequences are often obliterated with the high rates of the erosion. So we have a lack of ideal sites for studying long-term and short-term paleo-environmental changes. So karst poljes, as we've seen, represent excellent sites for multidisciplinary studies because they offer very valuable sources of information regarding the past geomorphological and sedimentological processes, which are often governed by dynamic climates of the late Quaternary, for example, changes in precipitation. And we can possibly track human influences such as pollution. Karst poljes in the Dinarides are characterized by combined alluvial and lacustrine sediments deposited within the karstic depressions. Some poljes were entirely...
Inova, I'm sorry, you have half a minute to finish.
Okay, yes, yeah, I'm finished now. Okay. So some poljes were entirely ancient lakes, but others only in some parts. And those along the eastern Adriatic coast were under the influence of the post-LGM sea level rise. These studies can be used for the correlation of terrestrial and marine records, but to do that, we need to do more detailed geomorphological and paleolimnological studies, with, of course, emphasis on coring, geochemistry, and always dating. So, thank you very much.
Thank you very much. You can see Nurit. It was a great trip to karstic geomorphology. Very interesting. Okay, let's wait for the questions, if there's any questions from the audience.
Yes, I would like to make a question.
Mm-hmm.
Okay, Isidore.
Okay, first of all, thank you for this enlightening presentation regarding the karstic processes in the Dinarides. I would like to ask you if you have done any comparisons with cave proxies with throughout speleothems. If you have found any comparisons in your data and the depicting environmental changes, if
Yes.
it was able to do that.
Yes, I will do that. I failed to mention that I am an early stage PhD student. I'm only in my second year. So many of my research is still in the process. As I mentioned, we haven't finished yet with the surveying. So definitely I will do some correlations with caves and possibly even with other locations within the Dinarides that we have conducted in the previous years.
Thank you. Yes, I know that.
If you have any suggestions, I will be very happy to hear them.
Yes, why not? I know that it's a painful process in order to do all these correlations, but you should do it, and I wish you all the best with your research. Thank you.
Thank you very much. I will do it.